This lesson is on factorising monic quadratics. Now, monic quadratic takes the form x squared plus bx plus c. Now, what makes it a monic quadratic is the fact that the coefficient of x squared is 1. So mono meaning 1, the coefficient of x squared is always 1. Let's jump straight into an example. If we want to factorise x squared plus 8x plus 15, I'm going to show you a method called the PSF method. P stands for product, S stands for sum, and F stands for factors. So, in terms of the product, we're looking for a product of this C term here. So we're looking for a product of 15. In terms of the sum, we're looking for a sum of this term here, the coefficient of x. So we're looking for a sum of 8. Alrighty, the factors, we're looking for two numbers that multiply to 15, so a product of 15, and sum to 8. So the first ones that come to mind are 5 and 3. 5 times 3 gives 15, 5 plus 3 gives 8. Now what we do with these two factors here is we can use them to write this expression in factorized form. So we'll use x plus 5 and x plus 3. If we want to check our answer, we can just go through and expand this here. X times x gives us x squared. X times 3 gives us 3x. 5 times x gives us 5x. So 3x plus 5x, that gives us the 8x. And then 5 times 3 gives us 15. Let's have a go at another example. Factorise 2x squared minus 10x minus 28. Now you'll notice that this one here at the moment is not a monic quadratic, but hopefully you recall that our first step whenever we are factorising an expression is to take out a common factor if possible. In this example up here, we didn't have a common factor to take out, but in this example here, we do have a common factor. We can take out the 2. So we'll have 2 outside of x squared minus 5x minus 14. Now we can go ahead and use our PSF method. We're looking for a product of negative 14, not just 14, it's negative 14 because that negative sign is attached to the 14. We're looking for a sum of, again, negative 5. Now we're looking for two numbers that multiply to negative 14 and add to negative 5. So we will get minus 7 and plus 2. Minus 7 times 2 gives us minus 14. Minus 7 plus 2 gives us minus 5. So with these two factors here, we can write in factorized form that monic quadratic component. X minus 7, x plus 2. And you'll notice the 2 just stays out the front. Alrighty, let's have a go at another one. Factorise x squared minus 8x plus 16. Same process, PSF. Let's product of 16. We're looking for a sum of negative 8. Factors, two numbers that multiply to 16 and sum to negative 8. We're going to get minus 4 and then minus 4 again. Minus 4 times minus 4 gives us positive 16. minus 4 plus minus 4 gives us minus 8. So we can use those factors to split up or write in factorized form this expression here. We'll get x minus 4, x minus 4. Now, in order to fully factorize this, we can actually take this one step further, because x minus 4 times x minus 4 is actually the same as x minus 4 all squared, which makes it a perfect square. Let's do one more question that's a little bit more involved. Question 4. Let's simplify x squared minus 9 over x squared minus 2x minus 15 times x squared minus 4x minus 5 over 2x minus 6. Alrighty, now what's going to help us in this process is to actually factorize as many of these expressions as possible. So let's look at the numerator on the first fraction on the left hand side. X squared minus 3 we can turn into x minus 3, x plus 3. That's a difference of 2 squares. The denominator down on the left hand fraction, let's use PSF. Product of minus 15, sum of minus 2, we'll get factors of minus 5 and plus 3, so that'll give us x minus 5, x plus 3. Let's come across to the second fraction. X squared minus 4x minus 5. If we do PSF with this trinomial, we'll get a product of minus 5, a sum of minus 4. Factors, it looks like we'll get minus 5 and 1. So this will become x minus 5, x plus 1. And this denominator on the right hand side has a common factor of 2. So we can take out the 2 and that becomes x minus 3. Now from here we can do some cancelling. Remember, when we multiply fractions we can cancel both diagonally but also vertically across the fractions. So let's cancel this x minus 3 with this one here. This x plus 3 can go with that x plus 3. This x minus 5 can go with that x minus 5. And we are left with x plus 1 over here over 2.